Hello, everyone. So today we're going to take a look at lessons 108, 109, and 110. Basically, they were all about solving polynomial equations. And we had a lot of different definitions in here and things to use in order to help us be able to solve. Okay, so a lot of these are used to help us narrow down our choices. So if you'll see there in our objective, it says to be able to solve polynomial equations using theorems to help narrow down our choices. Okay. So what we're going to do is we have one example, and I'm going to kind of basically walk through how we would use each of these different theorems or rules if we were solving and how they can help us narrow down our search. So the first theorem we have here is the fundamental theorem of algebra. This, I would say, is probably one of the most important or slash helpful because it tells you how many answers you have to have. Okay, so it says a polynomial of degree n must have n roots or solutions. So anytime you are given an equation and told to solve it, if you look at the degree, you know how many answers you have to have. So one thing to keep in mind is that the roots can be real and imaginary. Okay, so you could have one real answer and two imaginary, or you could have all real answers, or potentially all imaginary answers. Okay, but we know that the total of number of answers when we finish, the total number of solutions, total number of roots, whenever we finish solving, has to be the same as the degree. So that's a great way just to know, have I solved this or have I finished solving? If you don't have the same number of answers as the degree, that means there's more work to be done. Right? Our next theorem here is the complex conjugate root theorem. This is important because it tells us, as you see here, about our imaginary answers and our radical answers. So something with a square root. These must come in pairs. You will always have the positive and the negative version. So what that means is if we're thinking about imaginaries, it's impossible to have only one imaginary answer or three or five. You must always have an even amount. Same thing with a radical. Okay, and these are really the same because if we remember, I is the square root of -1. I is a radical. So we're saying anytime we have that square root answer, we must have a positive and a negative. Think when we square root, we add in plus or minus. That's why. Okay, if you think about the quadratic formula, in front of the radical is a plus or minus. Okay, so anytime you have a square root, you have I as those answers, you will always have two of them. One positive, one negative. All right. So now these last kind of four here, and this is what we're really going to spend a lot of time with, is these are all of these theorems or rules that will help us narrow down our search. Okay, so the rational root theorem, it tells us the number of possible real rational roots. So I'll say here, so rational is anything again that can be written as a fraction. So if one of your answers is a radical, won't be here. Right? If one of your answers is I, it won't be here. This is only going to give us possible, notice here, possible rational roots. Right? So it comes from this list of P over Q, and we'll get more into that as we look at that a little bit later. Okay. So the rational root theorem is just going to give us a list of possible answers. It's not going to give us the exact answers. It's just going to give us a list to kind of start working from. Okay. The Descartes rule of signs, again, is another kind of possible, but it helps us figure out how many positives and how many negative answers we're going to have. Okay, so the rational root gives us a list possible list of answers. Descartes' rule of signs helps us figure out how many answers could be positive and how many answers could be negative. Okay, so we have an idea. Again, we can kind of look to say, should I have two negative answers? But I only have one, so probably need another one. Okay. The bounds test is used to help limit where we are looking for our answers, because if we think we have an infinite number of choices from negative infinity to positive infinity. So the bounds test is going to help us narrow it down so we're not searching everywhere to figure out what the solutions are. Maybe we only have to look from -5 to +2. All my answers are just between those two numbers. So instead of looking everywhere, we have a limited search for that. Okay, and then our last one is this intermediate value theorem. So this is going to help indicate, so it indicates where a zero is. And again, I'm going to go more into detail with each of these. But basically it tells you if the y value changes signs, so if it goes from a positive to a negative, we know there is an x-intercept between there. Because if you think graphically, if this is my y-axis, anything up here is positive, anything down here is negative. So in order to go from positive to negative, I have to cross over 0 or have an x-intercept. Okay, so that intermediate value theorem can tell you, hey, you went from positive to negative. That means between those numbers, there's going to be an answer. All right. So our goal for today is kind of just to tackle each one of these so you can see how they can be used in solving. So we're going to work with one polynomial for the entire time and kind of go theorem by theorem to see how each of these work. So to start with, we have our fundamental theorem of algebra and our rational root theorem. Okay, so the first thing is that fundamental theorem. So we want to determine the number of roots, which means the number of answers we will have when we finish. To do this, all you have to do, I jump back, I'm going to do a lot of back and forth, is remember it says the degree. The degree is the largest exponent. So as a reminder, when I say the word degree, we are talking about the largest exponent. So I look through and I carefully see this has the largest exponent is 3. So this tells me that this will have 3 solutions. What those 3 solutions are, I don't know, but it has to be 3. Now, I can have an idea about them if I go back and I think about this complex conjugate. Those have to come in pairs, which means in order to get 3, I could have 2 imaginary answers and 1 real answer, or I could have 0 imaginary and 3 real. When I add these together, I have to get a total of 3. And since imaginaries have to come in pairs, it is impossible for me to only have 1 or have 3 because I need to be able to pair them off. So if there's only 1, there's no buddy. If there's 3, that's an odd number. They don't pair off. So if I have 3, that's telling me I either have all 3 that are real or I have 1 real, 2 imaginary. Okay. And real could be a decimal, it could be a fraction, it could be radicals, things like that. It's basically, would you see that number on the number line? Imaginaries means you don't. All right. So now that we know how many answers we want, let's start figuring out, well, what could these answers be? So our rational root theorem, again, is a list of possible roots, specifically rationals or things that could be written as a fraction. So to do this, to make a list, we need a p-value and a q-value. So I'm going to jump back again. So p are the factors of the constant. Q are the factors of the coefficient. So I need a p and a q. So again, p comes from the constant. Q comes from the coefficient. So in this case, both of them just happen to be 12. So that will make it a little bit easier. A factor is anything I can divide the number by. So I can divide 12 by 1. I can divide it by 2. I can divide it by 3, 4, 5 would give me a decimal, so not a factor. 6 works, no 7, no 8, no 9, 10, 11, and then 12. And then same thing here. This would be 1, 2, 3, 4, 6, and 12. So these are all of the factors. In order to get my list of roots, what I'm going to do is I am going to divide them. So I'm going to take every single P and divide by every single Q. So I'm going to do that one at a time. So to start with, I will take the number 1 and I will do 1 divided by 1, which is 1. Then 1 divided by 2. 1 divided by 3. 1 divided by 4. And then I've got 6 and 12. So I took P divided by every single number below it. Then I do that again with the next one. So it's a big list. Okay, so I will switch colors so we can see that it's a different one. So now I'm going to take 2 and do 2 divided by 1. So 2 divided by 1 is 2. Then I do 2 divided by 2. 2 divided by 2 is 1, which is already in the list, so we skip it and move on. If when you do the dividing, you get a number you already have, you don't write it twice because it's already there. You just get to say, great, it's already in my list, so I move on to the next thing. So then I would do 2 and 3. 2 divided by 4 is a half, already in my list, so I move on. 2 divided by 6 is 1/3, already in my list. 2 divided by 12 is 1/6, already in my list. So we only got 2 new possible answers from that one because we already had the other ones in there. All right, so let's just keep going. So I'll switch. Let's do 3 will be in green. So this will start with 3 3/2. 3 divided by 3 is 1. So again, already there. Put another check mark. I know it's already there. Then I've got 3/4. 3 divided by 6 is a half. Already there. 3 divided by 12 is 1/4. Already there. So I'm done. So that time I got 3 new answers. Okay, so keep on going through. So let's do 4. So 4 divided by 1. 4 divided by 2 is 2. 4 divided by 3. 4 divided by 4. So that 1, lots of them. 4 divided by 6 is 2/3, already in my list. 4 divided by 12 is, yep, to make sure I have it in there. Yep, 1/3, done. So that time I got 2. So kind of after that first round, we're seeing they're starting to repeat. So we're getting less and less and less. So 2 more, oops, 2 more left. Tackle 6. So 6 divided by 1. 6 divided by 2 is 3. 6 divided by 3 is 2. 6 divided by 4 is 3/2. 6 divided by 6 is 1. 6 divided by 12 is 1/2. So the only new one is the number 6. And then last but not least, what color haven't I used? Orange, light blue, did green, I'll do light green for this one. Okay, so then for 12, 12 divided by 1, 12 divided by 2 is 6, 12 divided by 3 is 4, 12 divided by 4 is 3, 12 divided by 6 is 2, and 12 divided by 12 is 1. So we only got one new one there. So all I did is take every number in the top, divide it by every number in the bottom, and I come up with this list. So I will write them out kind of, I'll write my final list here. So my final list, and I'll try and put these, I'll start with the integers first. So I've got 1, 2, 3, 4, 6, and 12. Then I've got, let's see if I'll go, let's do it this way. So I've got 1/2, 1/3, 1/4, 1/6, 1/12, 3/2, and 3/4. So this is my list. Now there's one thing I am missing. If I jump back, you'll notice this says plus and minus. Okay. Whenever we are taking these, each number always has a positive or negative version because we can divide 12 by both a positive and a negative number. Okay, because technically this is -12. So we could say -12 divided by 1, or we could say 12 divided by -1. So each of these have to have a positive and negative version. So I don't just have 1, I have 1 and -1, 2 and -2, 3 and -3. So each of these are technically two different possible answers. So right now, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I feel like I missed something. 5, yeah, definitely missing. Let me see. Okay, so I've got 1, 1/2, 1/3, 1/4, 1/6, 1/12, 2. Oh, I missed the 2/3. So sorry. Okay, so I got, yep. So then I got 2/3 and I missed my 4/3. Okay, so now I have them all. So in this whole list, right now I have 30 possible answers. We just made a list of 30 possible solutions or answers, but we only need 3. So I'm going to use these other kind of rules and theorems to narrow and limit this list down. So I'm not choosing from 30 numbers and trying to guess and check, well, which of these 3 could it be? Okay, so right now we have a list of possible answers and we have 30 numbers to choose from. And again, we only need 3 when we finish. All right. So the next thing we're going to look at is that Descartes' rule of signs. So Descartes' rule of signs helps us figure out how many possible negative answers we have and how many possible positive answers we have. Okay. So it says here to evaluate the function at positive x and negative x and then count the sign changes. Lots of times people struggle with just plugging in a variable and simplifying. So if that is you and that is something you're struggling with, what I recommend is picking a number and plug in the positive version and the negative version of that number. So what I mean is to start with, switch from purple, I'll do a blue. I'm going to start with just 1. I'm going to plug in 1, see what happens. So this would become 12 times 1 cubed, 25 times 1 squared. Now, I'm not going to figure out what this equals. What I'm going to do is I'm just going to figure out each piece. So 1 cubed is 1 times 12 would give me 12. 1 squared is 1 times 25 will give me 25. Negative 4 times 1 is negative 4, and then negative 12. Once I am here, once I have plugged in and simplified each individual term, this tells me to count the sign changes. So what I mean is I need to see how many times do I go from having something positive to having something negative and then negative to positive. So the first number I have is positive, and the second number I have is positive. So that does not change. Then I go from a positive to a negative. So this here, since I changed signs, this is one sign change. Then I go negative and I stay negative. So in the whole thing, I only change signs one time. Since I plugged in a positive number, this tells me that I only have one positive answer. So remember, I'm looking for 3 answers. Well, now I know that only one of them is going to be a positive number. Based on what I've done here with this rule of signs, this tells me only one of my final answers can be positive. Okay, and now I'm going to do the same thing with a negative. Now, logically, we can think about this and say, well, if one of them's positive, then the other 2 should probably be negative if I need a total of 3. But let's make sure that that is what we get. So I'm going to do the same exact thing, but I'm going to plug in negative 1. And you can plug in negative 2, negative 3, as long as it's kind of, I just like to have the same number. And 1 is just an easy number to work with. Okay. So this is where we got to be careful. Negative 1 cubed is still negative 1. Negative 1 times negative 1 times negative 1 is negative 1. When I multiply that by 12, I get negative 12. Okay, because this turns into negative 1. Negative 1 squared is positive 1. Positive 1 times 25 is 25. Negative 1, or sorry, negative 4 and negative 1 will give me positive 4 and then negative 12. So I say, okay, start at negative, change to a positive. So that's 1 change. I stay positive from positive to positive, but then I change again. So I see 2 sign changes when I plugged in a negative. So that means I can have 2 negative answers or 0 negative answers. And you might be thinking, wait, 0, but I have to have a total of 3. Remember, not all of our answers have to be real. So the other option is that we have our 1 positive and potentially 2 imaginary answers. So every time we use this Descartes rule of signs, we have to be subtracting 2 to see our total choices because we could have 2 imaginary. So for example, here, what I'm saying, I'll just do green. So I'm saying in the end, remember I need 3 answers. So I could have 1 positive and 2 negative answers, or I could have 1 positive and I'll say 2 imaginary answers. Both of these give me 3 total. So the question is, do I have 2 negatives or do I have 2 imaginaries? But I know I have to have 1 positive. And you might be wondering, well, why didn't I subtract from 1? Why didn't I take away 2 there? Because remember, we have to take away 2. 1 minus 2 is negative 1. I can't have a negative number of answers. If this was 3, then it would be 3 and 1. Okay, so we always take away 2 at a time from our possible answers because we don't know if those missing answers are imaginary. Okay, so I'll write underneath here. So if we do have 2 imaginary, this means we have 0 negative. But I know when I'm finished, I have to have 1 positive answer. So I know at least one of my answers is going to be real and it's going to be a positive number. Because in order to get to 3, the way the numbers work out, that's the only way possible. So I can't have 3 imaginary, and based on the numbers, I can't have 3 negatives. So I know I have to have 1 positive real answer. Those other 2 are in question. Are they negative or are they imaginary? That's all I know. All right. Okay, so let's recap what we've done. So we figured out how many answers we had to have. We said 3. 10. There we go. Let's see. There we go. Okay, so we said we had to have 3 answers. We then made this big list of answers, which we have now 30 choices. Then we said, okay, well, let's give ourselves a little bit more information. We now know for our 3, one of them will be positive, and the other 2 are either negative numbers or imaginary numbers. Okay, so now I know kind of when I finish the combination of what my numbers should look like. Okay. So our next little narrowing down test is the bounds test. The bounds test is what it is. It creates bounds. It says, don't search everywhere. So if I jump back again, right now, my numbers range from negative 12. Why does it keep doing that? There we go. Negative 12 to positive 12. So I've got this really big span. I can choose numbers from negative 12 to positive 12, and there's 30 in there. So what the bounds test is going to do is it's going to say, okay, instead of going from negative 12 to positive 12, I'm going to help you narrow down your search. Maybe you only need to search from here, or maybe you search from here, but you don't have to search or look at as many numbers as you were looking at before. Okay, so again, that bounds test is going to help narrow down the search of numbers. So to do that, we're going to use synthetic division. I usually start with kind of the 1 and then work from there. So kind of start from the beginning. You could do this with fractions, but synthetic division with fractions is not as easy. So I kind of start with the smallest integer, which would be 1. And then I would go to 2 and then 3 and kind of build up from there. Okay, so I'm going to start with 1. And I'm going to do my synthetic division. So this would be 12, 25, negative 4, and negative 12. So I bring down 12. So remember, for synthetic division, anything in the bottom gets multiplied with 1. So 12 times 1 is 12. And then we add up. So this gives me 37. 37 times 1 is 37. Add that up, I get 33. 33 times 1 is 33. Add that up, and I get 21. I don't care what those numbers are. What I care about is if they are positive or if they alternate. So if you look at your answers, I have positive 12, positive 37, positive 33, and positive 21. This tells me that 1 is the upper bound. So 1 is the upper bound. That means my answers that I'm looking for, none of them can be bigger than 1. The largest possible answer I can have is 1. So if I go back to that list that I made, I can get rid of anything bigger than 1. So positive 2 is gone, positive 3, positive 4, positive 6, positive 12. All of those are gone. positive 3/2, positive 3/4. Any number that is bigger than 1, chuck it. It cannot be an answer because we said 1 is the upper bound. Nothing can be bigger than 1. Okay. We also know that we only have one positive answer. So that means we're looking for something between 0 and 1. Because if nothing can be bigger than 1 and it has to be a positive number, that means we're limited. Somewhere between 0 and 1. So probably one of those fraction choices is going to be our answer. So upper bound, we see all positives. Great. Did it first try, got that one figured out. So now I'm going to go the other direction and I'm going to start figuring out my lower bound. So I'll start with -1, then go -2, -3, and kind of just keep going until I get signs that alternate. So I'll switch colors. So I'll start with -1 and see what happens. So I've got 12, 25, -4, and -12. So this would be -12. Add that up and I get 13. Make sure I go slowly so I don't mess it up. And this gives me -13. Add that up and I get -17. -17 times -1 would be +17. Add that up and I get 5. However, I could have stopped after the first column because I'm looking for the lower bound. And in order for it to be a lower bound, my signs need to alternate. I start with a +12, which means the next number I need has to be negative. It was positive, so not my lower bound. Keep going. Okay, so got to go lower than -1. So let's try -2. So I do the same thing. Okay, so this is 12, which is positive. So if this is the lower bound, the next number I see beside 12 has to be negative. If it's not negative, it means it's not the lower bound. Stop and move on. So 12 times -2 is -24. But when I add those together, this is +1. Signs did not alternate, not the lower bound. Keep going. So the next number would be -3. So I'm just kind of moving down my number line to create this range of answer choices. So this would be 12, 25, -4, and -12. So again, I'm starting with +12. So 12 times -3 will give me -36. Add that up and I get -11. Okay, so far so good. Positive than negative, I like that. -11 and -3 will give me +33. Add those up and I get +29. Great. So switched back. So I'm seeing some alternating. So it comes down to this last number. So 29 and -3 will give me -87. Add those up and I get -99. So I see the signs alternate. So that means 3. Oops, sorry, -3. -3 is the lower bound. So all of the answers that I'm looking for, this one positive and potentially 2 negative answers, have to be between -3 and 1. Okay, so if we're thinking number line, if I do a number line, when I started this, I had possible answers that ranged all between -12 and +12. From that list that I made, I have answers all the way from -12 to +12. Based on this bounds test, I know all of my answers can only be in this portion. So any answer that is not between -3 and 1 get rid of it. It cannot work. It is not a possible solution. Okay, so if I go back to that answer, so that means -4 and +4, gone. +6, -6, gone. +12, -12, gone. Okay, I can keep 1/2, positive, negative, 1/3, 1/4, 1/6. So these can all stay. 3/4 can stay, 2/3 can stay. And then I've got my positive -1 and -3. So I went from 30 possible answer choices to 2, 3, 4, 6, 8, 10, 12, 14, 16, 18. I almost cut them in half. Okay, so by bounding it and narrowing it down, I got rid of almost half of these as possible choices. Or I guess I forgot this -3/2, but still a lot less. Okay. Now, if you're thinking, we could actually eliminate -1, 1, and -2 as answer choices. Because in order for something to be a zero, remember the remainder, well, I guess we could eliminate all of these, and I know I didn't do -2. The remainder must be 0. None of these numbers gave me a remainder of 0. Potentially. Realized I didn't finish -2, so I'll say potentially for a second. Okay, so if it doesn't give you a remainder of 0, we could technically eliminate 1, -1, and -3. We didn't finish -2, so I won't eliminate that. But I can eliminate, I guess, positive and -1. -3 can go. So -2, I don't know. All the fractions stay. So in that synthetic division, you could potentially also find an answer if you end up with a remainder of 0, or eliminate an answer if you don't get a remainder of 0. Okay, so our intermediate value theorem. So this can kind of work with the bounds test. What you're going to do is you're going to be evaluating with integers, and just like before, seeing if a sign changes. Because again, if a sign changes, if you go from having a positive answer, I don't know why there's two of these. If you go from having a positive answer to a negative answer, that means you have to go over 0 or have an x-intercept. Okay, so kind of what I'm going to do is I'm going to work with all of our integers that fall within our bounds, because we said -3 is the smallest number, +1 is the biggest number, so I want to see where could those missing answers be. So all I have to do is plug in to get my answer. Nice thing here is we already have a few of these answers. Remember, the remainder is the same thing you will get when you plug in. So I know when I plug in 1, I will get 21. When I plug in -1, I will get 5. When I plug in -3, I will get -99. So I'm really just having to figure out what happens when I plug in -2 and what happens when I plug in 0. Okay, so I'll do that very quickly on my calculator just so we can all see. Oops, I share. Okay, so let's start with 0 because that's probably the easiest one. So I do 12 times 0 cubed plus 25, and you might hopefully can do this in your head because all of these zeros will disappear. -4 times 0 minus 12, so I get -12. Okay, and then if I plug in -5, 2 for all of them. 2. I get 0. Really love that because now we have even more information. Okay, so let's go back and see all of what we have now figured out just by plugging in. So when we plugged in -2, we got 0. So that means this is one of our answers. Because if we get a y value of 0 or a remainder of 0, that means this is an x-intercept. So we know one of our solutions is -2, which is great because it's a negative number. Remember, we weren't sure, do we have 2 negatives or 2 imaginaries? Well, I just found one negative, which means there's another negative answer in there. So I can figure out where that goes. Okay. So then I had 0 gave me -12. Well, notice here, this is +5. This is -12. So I change signs, which tells me there is an answer somewhere between 0 and -1. Because the only way to go from having a y value of 5 to a y value of -12 is to cross over the x-axis. So somewhere between 0 and -1 is another answer. Then I see here, negative to positive, another sign change. So that tells me I have another answer there, which makes sense. We needed one positive answer, and so it has to be between 0 and 1. We have just confirmed that because the signs changed, so we're on the right track. What we did earlier is proof here. Okay, so we're missing one negative and one positive. So if we look at our list, now we have this crazy list, we can kind of rewrite what we have. So our possible answers from that whole list have been narrowed down. For this positive one, it could be 1/12, 1/6, 1/4, 1/3, 1/2, 2/3, and then I think it is 3/4. Yep. So one of those is our final answer. Okay. Now we know for the negative, it could be our negative of each of those. -1/12, 1/6, -1/4. So we took a list of 30 possible answers. We have found one of them through our process of kind of testing things out. And we have narrowed our second two down to 1, 2, 3, 4, 5, 6, 7 choices each. So I only have 7 possible answers here left over. I guess 14 total, but 7 kind of each number. So let's put it all together and find those missing answers. If we had not found one in the process, we could go to our list and just kind of start checking and seeing, well, which one works. Through the process of narrowing down, finding our bounds, all of that, we discovered that one of our answers is -2. Well, once we have one solution, we can use synthetic division, get this down to something that can factor so we can find our other answers. Okay. Again, if I did not find this in the process, I would go back to my list, see, well, what numbers do I have left after eliminating, and start doing synthetic division. We don't need to guess and check because we found one in our solving process. Okay, so I will take my -2, and now I will finish that synthetic division that I didn't finish when I was doing the bounds test. Okay, so This was negative 24. Add it up to give me 1. 1 times negative 2 is negative 2. Add that up to give me negative 6. Negative 6 times negative 2 is 12. And there is that remainder of 0. So now that tells me I've got 12x squared plus x minus 6, which is a quadratic. It has a degree of 2. We are missing 2 answers, so we're going to get them from this quadratic because a quadratic has a degree of 2, which means it has to have 2 answers. And those 2 answers should be somewhere in this list unless they are radicals. Okay, so unless it ends up being a radical answer, we better have them in our list here. So you could go quadratic formula if you don't want to have to worry about factoring. I always like to try my factoring and show you all. So do my A times C, my grouping method. So 12 and negative 6 will give me negative 72, and my B value is positive 1. So if the B is 1, that means the numbers have to be very close together. And in order to make 72, I've got 9 and negative 8. Okay. So, because that will give me positive 1. So I've got 12, and it doesn't matter the order. I like to put the negative number first, but you could have done the other way around. So my GCF here would be 4 and x, leaving me with 3x minus 2. Over here, my GCF is 3x minus 2. So that tells me I am doing this correctly since the part inside matches. So my 2 factors are 3x minus 2, 4x plus 3. So if I solve these, which you might be able to do in your head, I get 2/3, which on my list, there's my positive answer. And then I get negative 3/4, also on my list. So my final solutions would be negative 2, 2/3, and negative 3/4. 1 positive, 2 negatives, just like we said, all that fall between negative 3 and positive 1. So all of the tests that we did match with what we got in the end. We ended up with 2 positive answers, 1 negative answer that fall within the bounds, and all of our answers were on that original list of possible roots. Okay. The only ones that will not be on the list will be if it is imaginary or if it is a radical. And you will get all of those by doing quadratic formula. Okay, so once you get to this step, if you want to go straight to quadratic formula and not even worry about factoring, do that because the quadratic formula will always work. Right? Okay, so let's take a look at one last thing here, which I didn't kind of briefly mention, but we have our complex conjugate root theorem. Okay, so I'll jump way back to the beginning. So remember, our complex conjugate root theorem says that imaginaries and radicals come in pairs. They always have a positive and a negative version. So how this works is if you know one answer and it has an I or a radical, you automatically know the second answer. So this first one says, if a solution to a polynomial is 8 plus 3i, what must be a second solution? Well, I look in front of the I and I see a positive symbol. I's must have a positive and a negative version. So that means the other answer must be 8 minus 3i. I only change the sign of I. It is I that is a hidden radical. So I is the thing that must be positive and negative. Same thing if I see one that has a radical. If you are told, hey, one of your answers is 2 minus root 5, you already have a second answer, which would be 2 plus root 5. That is how that complex conjugate root theorem works. Anytime you have something with an I or a radical, you will always have 2. Okay, so just kind of an example. So if you got something that said, hey, I solved and I got 2i as an answer, well, then you know you also have negative 2i. Okay? The I always come in pairs. Or if you were solving and you got the square root of 3 as an answer, then you would also have negative root 3. That's what it means. I and radicals, you must always have a positive in front of it and a negative in front of it. They must have 2. So I know this was a lot, but hopefully seeing kind of each one of these theorems together and seeing how you can use it in one problem helped. But as always, if you have any questions, need anything, please don't hesitate to reach out, and I will see you all next time.